That's the moving up from the 60.3 meter span to the 64 meter span. And then, of course, direct maintenance cost is very important. And one of the ways we can lower direct maintenance costs by 5% is to reschedule some of the maintenance. If you look at this right now, 2C evolution is moved from 42 months to 48 months. The maintenance planning document is optimized. Evolution of the design, check to 2,000 flight hours in 6 months, been moved. You put all that together, and there's the bottom line. 50% less mechanic hours on that airplane over 12 years. 50% less man hours in maintenance over a 12-year program. And then, of course, with the electrical bleed air system, we've already got it on the 380, works extremely well. That picks up another 2% and improves reliability as well. So, summing all this up, I know there'll be a lot of numbers tossed around and a little bit of confusion from the guys in Seattle who are running around in circles right now. Here are the facts. And by the way, this is all guaranteeable to the airlines. Power plant gives us 11%. Now, some of you who are the aviation writers in the room will say, yeah, but isn't it bigger? There must be some more drag. That's true, it is bigger. That costs us about 1%, so you've got to subtract that out. What about weight? Aren't these new generation engines heavier? Isn't the nacelle bigger because the fan's 112 inches? Isn't the pylon going to carry more weight? Yes, it is, and that's going to cost us 2%. So I've got to subtract that out of the equation, but then I have 4% aero improvement for the 3.7 meter long wingspan and the new sharklets, and we put all that together, and this is per trip. So let's not get all tied up about how many seats are in an airplane, we stir it all up, confuse everybody. No, this is per trip. Per flight, 12% lower fuel burn. Now, with Kieran Rao's SpaceFlex, we can actually get between 6 and 10 more seats into the airplane than we do today. You divide that up, 6 more seats for a 300-seat airplane is 2% right there. It's very simple math. We improve then fuel burn per seat by 14%. That is game-changing, 14%. And that's the new interior. The new interior will have the same IFE, the same LED lighting, the same mood lighting, exactly the same as what's being offered on our own 350 and on the 787. The only way the passenger is going to know that he's not on a 787 is the seat's going to be bigger. He'll have the 18-inch seat, not the 16.9-inch seat, which, by the way, I cannot fit into. So, this is our new interior, 2-for-2 seating, 18-inch wide economy seat compared to 16.9-inch for my competitor. We also have increased cabin efficiency, what we call ICE. We have new designs, the lavatories, the SpaceFlex, the Smart Lab. We have a mid-underfloor crew rest area. Rather than trying to squeeze people in the overhead and losing bin space, we're putting them in the mid-cabin down below. It works very efficiently. So put all that together, and what are the numbers? Well, here's standard seating for the Dash 800 and Dash 900 Neo. So we have 252 seats on the Dash 800, and we have 310 seats on the 900. In terms of design weights, we stay at 242 tons right now, which is the same as we have today, or at least entering service next year on the 330. Today, we're not up to 242 yet. Engines, we've got the new Trent 7000, 72,000 pounds of thrust. Fuel capacity stays the same at 139,000 liters. Max passenger range, 7,450 and 6,200. Now, if you go to my competitor's website, you'll come up with some very strange numbers about range on their aircraft. And so before you write your articles, I don't want anyone to get confused. They talk about the 787-8 and 7,850 nautical miles, and their Dash 9 is 8,300 nautical miles. Well, that's with unrealistic passenger weights, unrealistic catering, unrealistic weight of the airplane, operator's weight of the airplane. But if I were to do the same thing, this is the range we would have to the exact same rules they've got. So when you're doing comparisons, don't use my realistic airline numbers at that middle line. Use their flaky numbers So our 7,450 airplane becomes 8,200, more range than a 787-8 by about 400 nautical miles. And honesty being honesty and everything, truth in advertising, I am short of range on the 330-900 by about 1,300 nautical miles compared to the way they would do the calculations. In reality, I've got a 6,200 nautical mile airplane and a 7,450 nautical mile airplane, and so do they, somewhere in that range. I'd give them 1,000 miles more on against the 330-900. Now, why am I not particularly worried about that? Because we cover 93% of all the missions that they can cover. There aren't that many people that actually want to fly to Antarctica. So if you really look at city pairs around the world, we think we've got the missions covered here very nicely. There's a range circle. Here's our 330-800 and the dark blue, and then our 330-900 in the light blue. From London, we can go all the way non-stop to Honolulu. So I hope Mark Dunkley is actually listening to this presentation today. But look at those ranges. We can also go down to Singapore, Jakarta, non-stop from London. Of course, we can fly back as well to serious airline rules. So if you compare the market today, you take the 330neo up against the 787, and what do we have? We have equal or slightly higher seating capacity, and we'll go out and draw that to any airline layout, probably about 6 to 10 more seats than they've got. Equal fuel burn to the 787, actually about 1% or so better, but who's going to argue over percent? Lower engine thrust required. We have proven airframe maintenance cost. Everybody knows how to maintain our airframe, and we even dropped the price of maintaining our airplane by 5%. That gives us 1% lower cash operating cost, but then with the drum roll, the real bottom line is, because we've already got a fully amortized airplane, we can offer it at very, very attractive pricing. Essentially, coming up with a game-changing airplane. Equal or slightly better cash operating cost, much better reliability, wider, more comfortable seats, and a significantly lower price. That when you factor all of that in, it's up with about a 7% lower cost for the aircraft. We launched it right now. As Fabrice said, this is an unconditional and unanimous launch by our board. They had their board meeting. They decided to go ahead and launch it. This is not an authorization to offer. This isn't how many orders are you going to get in the next 6 months, and then we'll decide what we do by the end of the year. Absolutely not. This is fully launched today. The A330 design freeze, Neo design freeze, will be at the end of 2015. And you can see the engine will start flying in the beginning of 2017. Flight test program. First airplane delivered to some lucky customer in December of 2017. And as Fabrice said, that's a record in terms of bringing a new aircraft to market. It's a record because we know how to build this airplane. We know what we're doing. We're building them at the rate of 10 a month right now. And we have very high hopes that the Rolls-Royce engine will not only meet these targets that we've got up here, but perhaps even exceed them. Eric, would you like to comment?
Especially exceeding.
Good morning. So first of all, we at Rolls-Royce are very pleased to be here today and to have been selected by Airbus on the A330neo as a sole source engine. It's very important for us. It reinforced the partnership we have between the two companies. As you all know, we are engaged on a certain number of programs, especially on the large fans. As we all know, the Trent 700 has been the natural selection, and is the natural selection on the A330. That's why we have about 70% plus of market share in terms of backlog. The 7000 really builds on that fantastic heritage. We'll benefit from the experience of the 700 with all of the maturity and in-service experience we have. We benefit from the architecture of the Trent 1000-10, and we also benefit from the technology we have now proven on the Trent XWB, which is the most efficient turbofan in the world today, and you will hear more about the XWB within the next few days. So with that being put together, we deliver, as John said, 10% of SFC, which is leading to 11% of fuel burn improvement at power plant level. It, as we say, doubled the bypass